Dear student, I am Dr. Harel Thomas, Professor in Applied Geology, Dr. Harisingh, Gour, Vishwavidyalaya, Sagar. Today, I will deliver my lecture on AFM projection. This topic I will cover under the following heads: Introduction, AFM, Projection and Calculation. Hope it will be useful for you. Try to be regular in course. In the ACF and AKF diagram, FeO and MgO plus MnO are grouped as one component. This simplification makes it possible to represent many observed mineral assemblages, but certainly not all of them. For example, in some rocks, biotite is present together with muscovite and one of the polymorphs of Al2 SiO5, kyanite, andalusite and sillimanite, whereas in other rocks, biotite coexists with garnet, sterlite, quartz and muscovite. These assemblages cannot be shown in the AKF diagram due to the simplification of treating MgO and FeO as one component. Although Mg and Fe+2 substitute each other in the lattice of silicate, the extent of this isomorph substitution is different for the various coexisting minerals and furthermore depends on the bulk composition of the rock temperature and pressure. Thus, in contrast to the ACF and AKF diagram, FeO and MgO are treated as two components in this case of AFM projection. This projection is particularly assemblages of peltic rocks except at the highest grade of metamorphism. These rocks contain muscovite. To cover the variation in muscovite bearing schist, Thomson in 1957 developed a projection based upon a tetrahedral plot of the four components. The four components are Al2O3, K2O, FeO and MgO, which occupy the four corners of a tetrahedron: A equal to Al2O3, K equal to K2O, F equal to FeO plus MnO and M equal to MgO. Any muscovite bearing assemblage can be represented graphically by projected each component's point in the AKFM tetrahedron onto the AFM plane by a straight line drawn through the muscovite point P. Every such assemblage contain muscovite and may contain quartz or plagioclase in addition to the phases connected by the line in the AFM projection phases. Those compositions lie on the tetrahedral sector PAFM projection within the AFM triangle itself. Example are almandine, sterlite, chlorite, chloritoid, etc. Others such as biotite located in the pyramidal sector PONFM plots below FM join, note that the point of K feldspar when projected along a straight line originated in point P intersect the AFM plane only at infinite. This is indicated by the arrow near the mineral potash feldspar. The geometrically projection of the point inside the tetrahedron on the AFM plane is carried out in actual practice by mean of calculation. First of all, the weight percent of oxide are converted to molecular proportion. A and M, which serve as coordinate, and these are calculated as follows: A equal to Al2O3 minus 3K2O divided by Al2O3 minus 3K2O plus MgO plus FeO. M equal to MgO divided by MgO plus FeO plus MnO. A value is thus excess Al2O3 after subtracting the amount of consumed in albite, anorthite, plagioclase and muscovite. The chemical formula of muscovite is K2O, 3Al2O3, 6SiO2, 2S2O, and therefore 3K2O is subtracted from Al2O3. If the A value for a biotite is calculated, it becomes apparent that this must be a negative number. For example, K2O, MgFe5, Al, Si5, Al3, O twice, OH twice, therefore A equal to minus 0.2, and therefore K2O, MgFe6, Si6, Al2, O6, OOH4, then A equal to minus 0.5. The AFM projection which has been described above apply only to the mineral assemblages containing muscovite and quartz as additional phases. Notice that in muscovite with formula KAlSi3O10 OH twice, the ratio of KAl is 1:3, and therefore 3 times of K2O as Al2O3 is subtracted from total alumina in the scheme of calculation to justify muscovite as a projection point and not represented in the AFM diagram. The ratio A and M were plotted for peltic minerals as if the extended AFM plane is a 2D graph. The AFM diagram shows the mineral assemblages and range of mineral solid solution at a specific pressure and temperature for all bulk composition. In the peltic system, the advantage of this AFM projection is that they allow the variation in mineral chemistry in the respect of Fe divided by Mg with changing metamorphic grade. Example, calculate the AFM values for biotite having the composition K Mg 1.5 Fe 1.5 Al Si3 O10 OS twice. AFM values are A equal to 1 minus 3 divided by 1 minus 3 plus 3 plus 3 equal to minus 2 divided by 4 equal to minus 0.5. M equal to 3 divided by 6 equal to 0.5. Dear student, today in this lecture we have discussed about the AFM projection. I believe this lecture was useful for you. In my next lecture, I will cover A-, F-, M- diagram. For further studies, please read the textbooks, references and links given in the text. Thank you very much.